Today we're going to look at some organic families. This is where we're going to get functional groups. Most of them have oxygen in them, and those functional groups give the different compounds properties that are much different than alkanes and alkenes. Generally, a functional group is the most reactive part of the molecule. I'm going to, if you want to just pause and write all of these down, like we do in lecture, you can, or you can just keep listening and I'll start going through them. Okay. So our first two functional groups, and I wrote them in this format because for a lot of times it's a little harder to see them and understand them when they're written this way. So I want you to be used to it. These first two families are similar. They both involve a carbonyl group. This is a C carbon double bond oxygen group. It can be on an end or not on an end. It doesn't have to be right in the middle, but anywhere other than an end. The difference is when it's on an end, there is a hydrogen right here, and when it's not, there's no hydrogen on that carbon, and this situation makes that hydrogen more involved in chemical reactions. So that's why there's a big difference. But anyway, so from your notes, do you know what these families are? Well, the aldehyde is the one with it on the end. And the one where it's not on an end is the ketone. So let's name these. On the aldehyde, if you were going to number it, you would number from this end because you always number from the functional group. Okay. However, this one we don't really need to number the carbons because we do not have to say the position of the functional group on an aldehyde because it's always on carbon number 1. So you don't, in fact, it's wrong to specify that the functional group is on carbon number 1. Now, if you had other groups coming off of this, they would have numbers. If you had a methyl or something, and their numbers would be set up by where the functional group is. But anyway, so this is a 3 carbon, so it's prop. Now, so the ending al tells you it's an aldehyde. And so that's what we're going to see is that the endings will tell you which family. On a ketone, the rule is you always give a number. And I'm going to write this. Let's go ahead and add that over here. So on a ketone, you always give a number. This one is in the middle, so it doesn't matter which end I number from. It's going to be number 2. So I'm going to name this. It's on carbon number 2, so I'm going to say 2, prop, and then the ending is on. Keep that in, on. Okay, so the endings kind of tell you which family. Let's look at a couple more. These two are kind of similar as well. They're similar looking, but they have very different properties because the sulfur actually has the same electronegativity as the carbon. So this one is totally non-polar. Okay. Let's talk about the families. Family with this OH is an alcohol. And the family with the SH is the thiol. Again, we're going to have to number this to say where the functional group is. On an alcohol, the OH can be on any carbon. And so we will say 1, and then propane, and then the ending is OL, like alcohol. The thiol kind of has a different way of naming. You're going to say the whole alkane name. So this is 1 again. So it's 1, and then the whole alkane name, propane, but then you end you say the whole part, thiol. Next, we have 2 compounds that are kind of similar. These are actually in 2 families. These are both, so definitely compounds can fall under 2 families. The first family that we're in, they're aromatic. And that's because of this benzene ring. Remember, there's 2 ways to draw a benzene ring. One is with the circle, and one is with the alternating single and double bonds. And having one of those makes it aromatic. These are also alcohols. And because they have the OH. Okay. This particular one is a very specific alcohol. This alcohol is called phenol. It is a common alcohol, pretty common, and it's used in some, it's used in like stuff to help numb your throat when you've got a sore throat, like chloroseptic, some cough drops. It's also used in some dyes, like in biology, have you used like phenol red? It has a smell, maybe that's real familiar. It smells like, to me, it smells like chloroseptic that you spray on your throat. But anyway, that's phenol, and it's a common one. So because it's common, we name other compounds based on it. So this aromatic alcohol over here, we could imagine that it's based on phenol, that this part is the phenol, and then of course this represents a methyl group up here. So what I'm going to do is I'm going to say where that methyl group is, so you can guess where my number 1 carbon is. It's going to be where the OH is. And then instead of counting around this long way to get to my branch, I'm going to count this way, and so on. But anyway, so I'll put this name together. I talk about the branch first, 2-methyl. And then the last name is phenol. Okay, so those are kind of a subset of alcohols to think about. Okay. This next one is kind of different because it's named in a different way. This one's interesting because instead of having a carbon on this chain, so we have a chain, and we have carbons in these other locations, but here we have an oxygen. So that's the first time we've seen that. It's named differently. We don't find the longest carbon chain. What we do is we name the groups on either side of this oxygen. In other words, this group versus this group. And so you know that this group is a methyl, and this group is an ethyl. And so we put together our name. We put together the name. We're going to say methyl and ethyl first, and we don't have to number, but we want to be alphabetically first, right? So we'll do ethyl. And this one actually has a space, methyl. And then the last name is ether. Oh, and I didn't tell you, the family that this is in is the ethers. That's the family. Okay, let's look at some more naming, and now we'll have some branching on them. And remember, so far we're going to number by the functional group. Well, we always number by the functional group. For All of them except the aldehyde so far, we have to say the number of where the functional group is. On the aldehyde, we never say like 1 butanal, because the aldehyde group has to be on carbon 1. So first we number according to the functional group. So I'm going to number from the end closer to the functional group. And then I'm going to recognize my branch. That's a methyl. And then I'm going to put together my name starting with the branch. I'm going to say 5-methyl. And then the last name, I will say I need to give the number first for where this hydroxyl group is, this alcohol group. It's going to be 2. And then it's 6 carbons, so I'll say hex nol. Okay, let's do some more. So here's an aldehyde and a ketone. This is a ketone. Got an extra letter in there somehow. This is a ketone, and we always number a ketone. You number from the end closer to the functional group. This one has a branch. This branch is a methyl. So when I put together the name, I'm going to start with the branch. 4-methyl. It has 5 carbons, so I'll say pent. And then ketone, I end it in -one. Known. Okay. Next one. This one is an aldehyde. And we're always going to number from this end, the end with the functional group. This one has 2 branches, both methyls. When I name it, I'm going to start with the branches. And so I need to give a location for each one. I'll say 4, 5. And then I don't say methyl, I say di-methyl. And then the last name, I don't say 1 hexanal because I don't say this number. It has to be on an end. So I just say it's 6, so I say hex nal, that al ending. So those are the new families. Our other topic for today is to start looking at attractive forces in these organic compounds. And to do that, I find that the easiest way to make sense out of this is to kind of sort your compounds into groups depending on how strong their attractive forces are. So I've numbered these groups 1, 2, 3, and you'll see on your handout I use the same criteria, but let's talk about what's in each group. And you guys, when we start talking about these attractive forces, they were covered in lesson 4 at the end. So if you need to go back and watch that video about attractive forces, read the PowerPoint about attractive forces, that might really help you with what's going on here. Okay, so our first category, we'll say these categories of compounds, and this week it only has one member. We'll get another one of the group 1 or category 1 next week. But anyway, it is, these are the ones that form hydrogen bonds well with self and water. Okay. And I want to tell you what I mean by form hydrogen bonds with self, because that's kind of strange. What I mean is that, this can't form a hydrogen bond with itself, but it can form a hydrogen bond with another molecule like it. So this hydrogen will reach out to another molecule to form a hydrogen bond. So the compounds that can do this, they must have somewhere in there an O to H bond, or if they have a nitrogen to hydrogen bond, that can allow for hydrogen bonding as well. But so you look in the molecule for O to H. And on this alcohol, this is an alcohol, a lot of times we write them like this on an alcohol, the OH together, and we don't show that bond. But there really is a bond in there, as I've drawn right here. Okay, I'm going to show how it hydrogen bonds to water. So I'm going to add some water molecules in here. Looks like I'm going to get a little crowded on this end. Yeah. There's some water. Okay, and so those are the water molecules. The hydrogen bonds are between the hydrogen on one and the oxygen on the other. So between this hydrogen, this oxygen, this hydrogen, this oxygen. So these little dotted lines are the hydrogen bonds. Okay, so that's the first category. They hydrogen bond really well. Let's look at the second category. These hydrogen bond a little bit, but not to themselves. Some, not very well. So they don't hydrogen bond to self. That means if you have a lot of these aldehydes fall in this category and ketones fall in this category, they won't form any hydrogen bonds amongst them. But if you put water in here, I'll draw a water in a minute, it can hydrogen bond to that. So these have this, they have to have oxygen and or nitrogen, but they don't have the O to H or N to H. So this one is like that because it has the oxygen, but it doesn't have a hydrogen that comes right off of it. Let's show how it can hydrogen bond to water, even though it can't if it's by itself, if it's the pure compound. Each oxygen can bond to two hydrogens. And I didn't show all of those possibilities up there, but there were definitely, I could have drawn two more molecules up there. Anyway, so here's our hydrogen bond between this water and this oxygen. Okay, so they form hydrogen bonds, but not super good at it. The last category have the weakest attractions. These are your non-polar molecules. And as far as elements go, we're kind of sticking to just 4 elements. We're looking at C, H, N, and O because those are the most common elements in the body in biochemistry. And so with biochemistry, you can do a lot just with those 4 elements. So there may be other possibilities, especially in this middle category, as far as other elements they could have and be in that group. But as long as we stick to those main elements, that's true. Anyway, so for this compound to be nonpolar, we always say these are the C and H compounds. but they also could have sulfur, and that's like the thiols. So those compounds are totally nonpolar. They don't form hydrogen bonds. These only form dispersion attractions. And those are the weakest type of attractions. Okay, so let's kind of summarize over here. What we can do is we can make some general comments or trends about these. Let me see. So one of them is water solubility. In order for an organic compound to be soluble in water, it needs to form attractions to water. So if we have a trend at the top, these are most water soluble. And we could say down here, least water soluble. As far as families go, that's how it works. And then for boiling point, remember boiling point, to boil, the more the molecules are stuck together, the higher you have to heat them. So the ones at the top with the strong attractions to themselves will have the highest, I should say, yeah, let's say highest boiling points. I'm going to use BP for boiling point. Okay, so we have those trends, and this is the trends for the families. If the size is approximately the same, these are the most important factors. Okay. If the size is not the same, then you have to consider how these factors are affected by size. I chose two molecules with the same functional group, so to kind of make that the same for both, or the controlling feature, but just changing the size. And so for boiling point, we need to know that attractive forces add up, and that's the important thing. With boiling point, all that matters is how much they stick to themselves. Like when you have the pure compound, how well it sticks to the molecules are sticking together themselves. And so if you remember from lesson 4, dispersion factors add up, and it's dispersion attractions add up. It's because if you have two of these molecules near each other, there are going to be a lot of atoms in contact. You know, they may have, when you start thinking about all the hydrogen atoms that are really on here, they may have 8 or 10 atoms in contact, and because of dispersion attractions, atoms are attracted to atoms. So this one will have less atoms in contact, so this one will have a higher boiling point. Okay, with water solubility, it's a little trickier, because what matters for water solubility is attractions to water. And so on both of them, you know, this part is really attracted to water, and water interacts with that well. The problem is that this part is hydrophobic. It's not stable for water to interact with that part. And because this part is the hydrophobic part, and this one has so much more of it, this one will be more water soluble. And on this one, we'd say the reasoning and if we want to say reasoning on this one, we would say Okay, that's the reason. Well, with that, you should be able to do your teamwork exercise, and be sure to do that. This stuff is important on the next exam, and I've posted a key.